Okay, latch nut. Next one. Now there's a couple different ways you can do this, and I'm going to show you several ways to, like 3 different ways to model this part. It is in inches also, so make sure again that you set it to inches. Look at the latch nut. The overall size of this part from top to bottom flats is 0.625 inches, so a little more than ½ an inch tall, so it's like a ½ inch nut. And then it has, so it's got a nut which is hexagonal, 6 sides, and then it's got what I call the spindle out front. Okay, and the spindle is got a convexed, convexed is inward. The outside radius of that is 0.531. The outside of this is 0.531, and it dips down in between. Now this note here says 0.063 by 45 degrees. That's pointing to this chamfered edge, if you will. Okay, it's a countersunk, and that's how they designate a countersink or countersunk, is that they tell you it's 45-degree angle. 0.063 is the leg of the triangle. If the chamfered edge is the hypotenuse of a triangle, the 2 legs would be 0.063 inches. Probably that's a round off. It's probably 0.0625, but we'll deal with it. Diameter 0.3125-18 tap. What is that? It's calling out a thread size. So 0.3125 is, I believe, 5/16 of an inch in decimal format. Everything's decimal format nowadays. -18 means 18 threads per inch. In English units, they give you threads per inch. So that -18 means threads per inch. Tap means it's tapped with a tap tool. If it was a metric thread, it would be given as inches per thread. It's called the pitch, and it's the inverse of threads per inch. It's inches per thread. So in other words, what is it? How many inches or how many millimeters is it from the top of one thread to the top of the next thread? Okay, but in English units, that's how we do it. Diameter 0.531 is the outside diameter of this this washer type looking feature, and 0.018 thick is the thickness of it, so it's like thin, like a washer. In here they give you a radius, so an inward radius of this arc is 0.125, and it says neck diameter 0.447 minimum. What that a neck diameter is the narrowest. Okay, it's at the neck of this feature. So and when it says minimum, that means 0.447 is the minimum it can be. It can be larger, but it can only be 0.447 minimum. And the thickness of the nut, or the width of the nut, is 0.188. Okay, now back here, 0.031 chamfer, and it points to this chamfered corner. What do they mean when they chamfer the corner? Do they mean that that is a flat face, like you took a file and you flattened it off with a file or some other tool, and it's a flat face? Or did you create that chamfer by spinning the part on a lathe or machine and having it cut off the corner? In which case that chamfered corner would be actually rounded. It'd be a curved surface. I really don't care which way you make the nut. The function of the chamfer is to protect people's delicate little fingers. Okay, when you have a nut with sharp corners, you can scratch somebody's fingers. So square corners are typically taken off of parts that people handle. Okay, so first thing we're going to do is create a hexagonal nut. So I'm just going to do some sketching. So on the profile plane, because that's the orientation they model this in, I'm going to create a polygon. Polygon, here it is, staring me in the face also. Let's go to polygon. You click at the center and 6 sides, right? Rotation angle, we're just going to click it now. We want the flat this way, right? So if we go 30 degrees, that'll put the flat top and bottom. Cool. So there's our polygon. And let's extrude that. And I'm going to extrude it the back way, so 0.188 backwards. I think I did some, well, okay. We're going to go back into the polygon. So I'm going to double click on sketch here. Okay, I got to put in a new size. So from the top to the bottom, or bottom to the top, it's not 12 inches, it's 0.625 inches. Oh, because we got to get rid of this one. 0.625. Boom. Much smaller. Finish it. There we go. Now it'll be the right thickness. There we go. Zooming in. And we're going to do, we want to cut these off with a revolve. What if I wanted to just cut a flat corner out of here? How would we do that? If we did a sketch on this face, .031. I think I did that wrong. Got a mushy keyboard. And if I put another line this way, let's go, oops, finish. That'd be 1. Let's go back into that sketch. Okay, let's put another line from here. 0.031 this way. So if they meant the chamfer was like that, and just so that we can see these lines easy enough, when we get out of the sketch, we're going to do that. Okay, now we can see it. 1 point, 2 points, 3 points make a plane. I'm going to go onto this face and I'm going to draw another line. And what I'm showing you is how to cut a small corner off. Yep, see, we can't see that. Can't see it when it's on top of another line, so I'm going to draw another from here to there, just so you can see where those two planes are. Okay, so if I want to cut that corner off, I could use the trim body as we've done in the past part, or I can do a extrude. We have to do it on a new datum plane. We could put a datum plane on these 3 points. 1, 2, 3. Now that datum plane is on those 3 points. We could use that as our trim plane, or we could even do an extrude, highlight that plane, and draw some geometric shape larger than those 3 points, or exactly on those 3 points. We could draw a triangular sketch. Finish it, extrude it outward, and subtract it. 2 different sketches, a datum plane and a subtraction, and we have 1 cut off. Do that 12 more times. No, there's a simpler way, which I'm about to show you. This is called pattern feature. So we're going to create And we're going to take a feature and we're going to make a pattern of it. So we're going to copy this feature around 6 times. Forgot to change the layout. We're going to do a circular, and then our choices is count and pitch. And the pitch is the angle between one copy and the next. Since there's 6 of them around a 360 degrees rotation, it would be 60. If you don't know, it's 360 divided by 6, or divided by the count, and the count is 6. So 360 divided by the count is the pitch. We need to rotate it about a vector. I thought ahead. I put a vector in the center of my polygon because I knew I was going to do this. So my inferred vector that I'm going to do the circular array is right there. X vector. I could have also clicked on here and chose the X coordinate. Select the feature that you want to copy. You need to highlight it. You need to find it. Sometimes it's hard to find, so what you can do is you actually find it by clicking over here on it. There we go. And then I'm going to say, now the method, simple, most things work with simple. If for some reason it crashes, you either made your sketch wrong, your feature wrong, it's not constrained right, or it's a very complicated array or copy that you're doing, in which case you can try variational, which uses a different algorithm. But usually simple works with all methods. And I'm going to say OK. Notice it gave me those white boxes that's showing it where it's going to go. And that worked. Okay. Now we're going to do a mirror feature. And we're going to pick, I need to pick a plane. And I don't have a plane down the center, so I'm going to pick and create a new plane by picking that face and then moving that face this direction. What is half that distance? Half that distance is 0.188, the thickness of the nut, divided by 2. And negative. Make that a negative. There we go. So that's what I'm going to do it about. The feature is going to be this feature, that feature. Hold your control key down and pick the pattern also. And then say OK, and it mirrors it about. Pretty easy, huh? Okay, let me back this up, because I'm going to show you another way to do the chamfer. And I'm going to get rid of all those sketches. There we go. So if it was a rounded chamfer, we would need to revolve that corner off. In which case, the chamfer distance is the distance from that imaginary corner down to the tangent of that curve. In which case, we have to create a cutout. We got to do a sketch on a new datum plane. Let's create that new datum plane from corner to corner to corner. On this datum plane, we would create a sketch. Highlight that datum plane, say OK. It should revolve it to that sketch. We are now on that diagonal sketch. Top or bottom, I'm not sure. We're going to do a profile from here, and I'm just going to guesstimate it. Okay, so we're going to go from, now that one is already left to right. Okay, we just have to move it. So from this line to this line, that distance is, I don't know what that is. Analyze. Measure from point to point. .7217. So if I go back to here and put a distance from here to there, that should be 0.7217 divided by 2. Well, that wasn't the optimal way to do it, but I guess it worked. Let's go back to a profile line. And let's create that. We're going to revolve both of these things. So let's put a, let's do equal length line. And let's make this equal to that. Let's also make them collinear. And let's make the distance from here to here 0.188. Okay, so we have those two sketches. They're on the bottom there. Okay, let's do a revolve. Let's pick that last sketch. Let's pick a vector to revolve it about. And let's pick subtract. And say OK. There you go. The spindle is a revolve. Let's pick this plane. Let's draw a sketch. That little washer thing out here, down to the center, over to there, up to here. And then I'm going to do an arc from endpoint to endpoint. Let's put some constraints in. Horizontal, just to make sure. Apply that. Vertical. Vertical. That one. Apply it. Horizontal. This one. Apply it. See if we can move anything. Yeah. Okay, so we need this one to be 0.531 is the diameter, divided by 2, that's the radius. And this one also, we can do it equal length. This one, this one. I think it already was. Okay, this line, 0.018. Now the radius should be 0.125, but the neck diameter is 0.447. They kind of fight one another. So I'm going to put in a distance, a neck radius, 0.447 divided by 2. And I wonder what the radius is, just coincident? Would be 0.189. If we put that at 0.125, it doesn't take it. 0.125. 0.125 divided by 2. 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 0.125 Oh, it moves the other line. Yeah. But we know this distance is 0.406 from here to here. This distance is the overall distance, 0.406 minus 0.188. And the distance from this to this line is 0 because they're touching. Double click. 0. There we go. You cannot satisfy both the neck diameter and the radius of that curve. They fight against one another. Since this says minimum, whenever you get a dimension that says minimum or maximum, never break those. So I think one is more important than the other. So there's our sketch, and then we're going to revolve it about, you can either do a vector, about a vector, or you can do a line. Will it grab that line for me? Right there. So there we go. And we need to unite it to the other part. I want to show you one other way to create this nut. Okay? So I'm going to delete this feature. And recreate that feature on that same plane. But I'm going to do it a little differently. And I'm going to put a circle on that sketch by 3 points. Where's my circle? By 3 points. In other words, you define a circle by any 3 points and finish that sketch. Okay? What I can do is I can extrude this circle negative 0.188. So it's the thickness, not subtract, but unite it, and say OK. I can chamfer it, these two edges at 0.031. And then I can extrude the hexagonal, extrude the hexagonal, not a single curve but connected curves, this way and this way. And I'm going to use a new Boolean operation called intersect. And intersect, if you have two objects intersecting, it saves whatever solid is a subset of both shapes. It deletes everything that's not a subset. So when I pass the hexagonal shape through the outside circle and the spindle, I get the solution. Now, what did that do? That did it. This is what you call planning your attack. This is an elegant solution. I did not have to draw sketches to cut that off, right? To cut that chamfer off. I used the chamfer command to cut them all off. And then I used an intersect command. So this is what I mean by planning ahead. Okay, very elegant solution. Last thing on this is the hole command. And I'm going to do a threaded hole. I'm going to pick the center of this edge, okay, which is the center of that face. I'm going to find the size, which if I'm not mistaken, it's 5/16-18. Okay, decimal equivalent is 0.3125. Hole thread depth, well, as long as it's longer than 0.406, the width of the whole part, that should be okay. Let me get the full menu here. There used to be some other things in here in version 11. Extent, start. This should be fine. Should say OK. Oh, okay. So it gave me these. Let me go back to here. Right click and say edit parameters, because it gave me chamfered edges on a hole. And oh, here it is under chamfer. I don't want to start and end chamfer. The part didn't call for it. Well, it called for a chamfer, but not that size chamfer. So you gotta turn that off. Okay, now this is what you get when you get a threaded hole. It gives you the hole, the nominal hole size, the minimal diameter, and it gives you a dashed line. The dashed line represents the thread, the bottom of the thread. Now I'd put a chamfer in here, and that chamfer is point, what is it, 0.63. And that's what you should have. And on the back side, you still see a representation of the thread. NX can do a real thread. They got a thread command right here. And if you pick that thread command and pick the thread, and up here instead of symbolic you said detailed, this might give you an error because we already have a thread in there, a symbolic thread. But that's what it gives you. Okay. The problem with actually creating a detailed thread is that when you, let me save this file. Let me open up my border template, and this is in inches. When you bring in a detailed thread, go to base view. Go to Latchnut, and let's make it bigger. Okay, and click them. It shows all those hidden lines of all those threads. Now in typical drafting fashion, we don't do that. Threads are represented by having a hidden line for the major diameter and a hidden line for the minor diameter of the thread. So if I go back into my Latchnut, what's the best way to move over there? And go to my part here, and get rid of the detailed thread. Delete that, and then save it, and then go back to my border template and right click on drawing and say update. This is how a thread is supposed to look in an orthographic view. Don't give me a detailed thread. Don't give me a blob of threads, hidden lines. As long as it's called out right on the program, it's going to, if you take this file and dump it to a 3D printer or a CNC machine, it's going to create it right anyway.